So I've been working on this tool called NAR, which is Data Exploration Tool. And as part of that, I've been building a lot of visualizations for the web. And in doing so, I've been using a library called Vega.js a lot. I found it's a really powerful library for quick data visualization and sort of declarative data visualization. So I want to give a quick walkthrough today of how you set up an interactive visualization on the web using Vega. We're going to do something similar to this. This is a bar chart where you can kind of hover and interact with extra labeling on the bar chart. So as part of today's setup and learning how can you use Vega to make something like this, we're going to use a scatter plot. But before we get into that, let's look at the Vega documentation itself. So Vega is a declarative kind of visualization grammar with a renderer for the browser. Essentially what that means is you can write some JSON to describe your visualization, and then it comes with some code that can take that description and turn it into an actual chart that you can put in your web page. You can see that it's like fairly simple to interpret the JSON. So something like this spec right here would describe this bar chart. But it's actually fairly complex, like what it's capable of. Like you can produce pretty sophisticated visualizations just using that JSON. So that was a simple bar chart, but I'll show you something a little crazier. If you go down to some of the custom visualization designs they'll show here, you've got like the classic wheat and wages type of visualization that again is created just with some JSON through Vega. Or you can create interactive brushing scatter plots like these, again all with just like a single spec. So I want to give you kind of an idea of how to actually do that and get started with Vega and the various components by actually building something. And as part of that, I'm going to jump back and forth between actual code and the documentation and examples, so you can kind of see how I've learned to do this stuff with Vega, and you have the same reference points if you try to build something with it. So what I have here is just a code sandbox where we have an empty HTML page and we have a data set. So we have this iris.json file that has about 1,000 rows in it with some data about flowers, and they're organized by species. And so what we're going to do is create a scatter plot with Vega that's going to plot a petal width and petal length against each other. And then maybe we'll add some interactions where, like, when you hover on the scatter plot, it'll draw a line to show you, where you're hovering, what the value is at that point on the X and Y axis. So let's get started. In this project, I have Vega as a dependency, which means I can start to like import and leverage kind of Vega in the browser. And so if you go to the documentation, you'll find a section at the bottom called Vega API reference. This is the JavaScript API that'll help you embed Vega visualizations into the browser. And specifically what you want to look for is the view. So a view is like an instance of a chart, like a runtime of a chart running in your browser. So the view is where you do things like manipulate that runtime, like change things about it, or of course instantiate it. So we can start by instantiating it just by kind of copying the basic documentation we have here. So I'm just going to copy and paste it, and we'll talk about what all this does. So I have a view, and it's giving me some warnings that I need to actually import stuff from Vega, right? So I'm going to import the view from Vega, and we'll update this to say, okay, we're going to create a new view. We're not going to do any logging for now, so we can avoid that. We'll render our scatter plot as an SVG. We're going to initialize it into this container that I've created in the browser, just like an HTML app. Now we have one last sort of error here, and that is this whole runtime aspect. So a Vega view wants you to pass it a runtime that it'll use to kind of execute that chart in the browser. And a runtime is actually created from a spec that's been run through one of Vega's parsers. So as you saw in the examples in Vega, we just create a simple spec as JSON, and we're going to fill this out with more information. But to turn that spec into a runtime that the View API can use, we're actually going to need to use the parse function that comes with Vega. So the parse function simply takes a spec and returns a runtime for it. So it's what makes our dynamic view possible. So now we have this set up. Now there's probably some issues here because we haven't really given the spec any details. There's nothing for the view to really put in here. If I inspect this DOM, we may find that there's like an SVG or something here, perhaps like an empty SVG. Yeah, there's an empty SVG, so at least we can see that our view is putting, an SVG object into that container, but it's not actually doing anything. Okay, so we've got the view set up. We're putting something into the browser. The next step is to starting to define that that spec. So if you go back to the documentation, this is really where the meat of the spec lives. At the top of the house, you have sort of like overall settings of a specification, but then the specification, as you're going to see, is going to have different properties that we're going to fill out as we build our chart. So start at the top level. We need to give it a schema. The schema is going to tell Vega what API it should use to interpret the spec. So we'll just use the existing one. In fact, why don't we just copy and paste all of this as an example? This is really good boilerplate for us. So we'll take this and put it in here for our spec. We'll zoom out a bit so we can look at our spec. Let's see here. So there's the schema. We have a description, which is not really useful to us here, so we can just delete it for now. We have a width and height of our desired plot or chart. Since we're going to make a scatter plot, let's just make it kind of like a square. Padding is area around the chart. This is something you might use to create room for your axes, so maybe we'll make the padding around it. We'll just start with 10 for now, and we can expand that later. Auto size is a really interesting feature that it will use to determine how to fit the contents in. It's a little bit outside the scope for this intro video, so let's just stick with the default pad, which will make sure that the chart and the padding all fit inside of our width and height. I believe that's what it does. Then signals we'll come back to later. Signals is how you define sort of reactive variables in a Vega spec. So how do you make it so you can have hover events that change attributes of the visualization and things like that. Basically anything that you want in your chart to be dynamic can be controlled through signals. But data of course is very important. So if we're going to visualize a data set, and we need to pass in data to the Vega view so that it knows what to run. This data can be embedded directly in the spec. More commonly, when you're building visualization on the web, you're going to want to programmatically insert that data, and I'm going to show how to do that later because it's a little bit more advanced usage of the View API. But for now, let's start by introducing this data from iris.json just directly as part of the spec and not dynamically. So what I'll do is I'll import this data. Just make sure I got that properly. Where did the console go? Let's see. There we go. Yep, so there's a bunch of data coming in, a bunch of objects. Okay, so we have the data set coming in. Now the format for Vega data is you kind of define tables. So it's an array, and the tables have definitions as objects, and each table has a name. So we'll call this just our source data. And then it has an array of values. And so in our case, our data set is already in that array format that we want. So this is important because the name is what we'll use later on in our spec to reference that data set. We want to create scales out of it, axes, whatever it might be. Or actually, create marks like symbols, or in our case, circles, based on that data set. We need to make sure we know what data we're working with. And then the values, of course, this is just an array of objects that we're going to be able to sort of access. If you look at our data, it looks like this. These are our values, right? Each object has a field like petal width, petal length, species, etc. So that's the simplest how you kind of define data. Now this information, there's more about it in the data section. You can define multiple tables, so you can have visualizations that obviously render more than one set of data. You can also do data transformations with Vega, so you could take a source data set and then maybe transform it or augment it in different ways to better match what you want your visualization to do. Now for this case, we're just going to stick with our simple single table. Okay, so we have a table coming in, so now Vega is at least aware that we have this data set, and we've given it sort of the width and height that our output should be. So the next part then is, okay, defining scales. If we're going to create a scatter plot, we need to take the data coming in for the petal width and the petal length and define sort of X and Y scales we can use to then position those properly in our SVG window. And there's a bunch of information on how to do this in the scales section. But I'll just start and show you how to create one. Again, this is an array because we have as many scales as we want that we can use later. And the first scale, we'll just call it our X scale. So we'll give it the name X scale. And we need to give it a domain. So we'll give it a type first, actually. So Vega supports various types of scales, linear scales, for example, for numbers, ordinal and band scales for kind of categorical stuff. Vega is built on top of D3, so if you're familiar with D3, all those type of scales are possible in a Vega spec. Now we're creating a linear scale because it's a scatter plot, and we're going to plot numeric values across a continuous scale. So we'll make this linear, and that scale needs a domain, and that domain needs to be the min and max value of our data set, right? In a scatter plot, we want it the X scale to start at the smallest value and end at the largest value to fit all our data points in there. If I look at this data, I could sort of calculate this myself, maybe iterate through the data and figure out what the smallest petal width is and what the largest petal width is. But Vega actually comes with helper functions for this. So if you go to the scales page in the documentation and go to the domain section, you'll find this information here about how you could provide sort of an array literal of the domain, like I want it to be from 0 to 500. But you can also provide a data reference, and this is super handy and why we named our table earlier. So with a data reference, what you can do is essentially say you want to base the domain based off a certain field in a certain table. And so we're going to copy this syntax and just change it for our own purposes here. So we have data, and our source data is called source, and the field that we want to use for this particular scale is going to be the petal width, I believe is what I said. Okay, so that is going to automatically loop through this field and figure out for us what the min and max values are for the domain, so we don't have to do that ourselves, so it's very convenient. Similarly, our scale needs a range to map to. So if we're going to plot this inside of our plot, when you have the smallest petal width value, where does it start and get plotted? If you have a large petal width value, where does that get put on this X scale? This can be done as an array literal as well. So you could say like, 0 to 500 if I was just kind of hard coding it to my height that I'm aware of. But you can also actually just reference, or width that is in this case since we're doing X. You can also just use a shortcut and directly reference the width or height. So width and height are actually signals in the spec, and they're special keywords in this case. Again, you'll find this in the documentation as well. So if you go to the range section, you'll see that there's some ways to pass in pre-existing range defaults, like a width signal. And so width is more or less going to essentially map the range from 0 to the width of our chart. So it's very helpful in doing that. And that's really it. Now we have an X scale that we're going to be able to use. We can copy and paste this and repeat it for the Y scale, just change some properties of it. Let's say the Y scale will do petal length. And instead of doing the width, we're going to do the height here as our range for the Y scale. So we're good there. The next is projections. Projections is related to kind of mapping and things like that. We're not doing any mapping here, so we don't need any projections. But what we will need are axes. So if we're going to draw a scatter plot and put some points on the page, we want to know, what are the values of those points inside of our grid. So obviously axes are very important annotations. And they're also fairly complex to make, but Vega sitting on top of D3 helps abstract that away. So if you go back to the documentation, you'll find a section called axes. And axes is going to have all the data, kind of the configuration settings you need to know about to create an axis. The first part of doing that is pretty straightforward. It's the scale. What scale do you want to use to construct the axis? Then there are settings like orientation. Should it be on the bottom? Should it be on the left? Etc. There are other settings you can mess with to kind of change how it looks, like the format and what color the different lines should be and things like that. To keep things simple today, we won't mess with those settings, but you can use that to really customize what your axes look like. So let's start by making an x-axis. We are going to use the x scale for that axis, and because it's an x, we're going to put it on the bottom of the chart. And if I pull this up, we see we now have sort of an x scale sitting here at the bottom, going from 0 to 2.4. So that's good, and now I want to repeat that and create my y-axis. I can just take this x-axis that I created and copy and paste it and change that to the y scale and put that on the left. And if I pull this up, one thing I neglected to mention here is that the way when you create a view in Vega, like you may have just noticed that like when I made my update, the chart didn't appear until I hovered over it. What happens is when you create a view in Vega, it's sort of like this instance. Let's pull this back down. That is able to render into this this container, but it only renders when you call the run function. The reason it does that is that you can kind of provide multiple changes to your runtime while it's happening, such as like changing the width and height on the fly when someone maybe based on a resize event, or changing what data is being passed, or changing some properties of the signals, which are the reactive variables. So to get this to really like run immediately, we actually need to call run here, so that for every change we make it in our code, when it gets initialized, it's automatically rendered to the browser. And again, if we wanted to make other changes before that, we could have kind of chained in some things like change the width, change the height, whatever it might be. Like for example, if I want to make this smaller, I could have said make the height 200 instead of 500. So you can see here now it's sort of overriding the values that started in my spec. And in fact, to keep this simpler, maybe we'll leave this at this size so that we can see without me having to constantly resize the browser here. Pretty cool. So you can see Vega's like kind of reactive already, even though the spec defined kind of a default value of 500 by 500. On the fly, you can change what those values are and rerun the view to get a new view with updated values. Okay, so let's go back to our spec definition. So we've got axes going, so we're really almost there in terms of having a scatter plot. In this case, Vega also helps you create legends, but in this case, we're not going to use legends because our scatter plot's just going to be some simple circles. So we can delete that part of the spec as well. But now we can get down to the most important part, which are the marks. So marks are how data gets drawn into the actual plot area. It's how you produce circles or text based on the data, rectangles, whatever it might be. So there's a bunch of documentation, of course, on how to create marks and the various types there are, like arcs and areas, groups, lines, paths, rectangles. In our case, we're actually going to go with symbols. So we want to create a scatter plot that draws circles on it, and a circle in this case is going to be a symbol that we can leverage. So we can go down and look at sort of the documentation for the symbol. The symbol is going to inherit kind of the general mark properties, which we'll see in a minute. In fact, let's go back to the general mark properties to see how we create one. So this comes from a bar chart example. We can see it has rectangles, right? So to create a mark, you essentially create a JavaScript object that describes that mark. And in that, you can tell it what should the mark be. And you can also join it to some data. You can say make multiple of these marks based on some incoming data. So let's do that, but instead of using a rectangle, we're going to use a symbol. So we're going to come over here to our marks section. We're just going to have the one mark to start off with. That's going to be a symbol. And you can see it put a little default little circle right up there at the top. So this by itself just created like a blank symbol. And if I wanted to like move that symbol around, I can use the encode property. So the encode property is going to have allow you to sort of change what happens to the settings of this this symbol based on 3 different types of events. If you're familiar with D3, this will be super familiar. If not, it may be new to you. There's essentially a concept of enter, exit, and update. So enter would be like when the symbol gets created for the first time. So when the data gets added for this particular symbol, what should it do initially? Exit would be when this symbol gets removed, what should happen? How should it look as it's getting removed? And then update, in fact, I don't know if Vega actually has the exit piece. I have to double check that. But update would then be, okay, as the data changes, what should the symbol do? So if you want to do stuff based on data properties, you should use update. We're going to start with update for now because later on we're going to want our thing to be dynamic. And so in update, what you can do is you can put an object with any of the kind of marked properties you want to manipulate, and you can give them values. So in our case, let's say we want to move this circle, to the 100 by 100th coordinate. Well, we want to change the x value then. And there are multiple ways to describe the x value for Vega, but the simplest way would be to give it a literal value. And the way you do that is with an object with the property value, and you just put your property in there. So that's how you do kind of value literals, like literal values inside of a Vega spec. So for y, I can do the same thing, and this would give me kind of the point at 100 and 100. Okay, so that's so far so good, but it's really just one point, and we want this to be data driven. So we don't want just one symbol. We want like 1,000 of these symbols from this file that we imported. We want the x and y positions to be based on the data of that. So the first thing we need to do is actually just like tie this symbol to some data so we get multiple symbols, and that's done with the the from property. So in the from property, again, if you consult the documentation, from allows you to define a data set that you want it to kind of draw from. And when it says draw from, what we mean is that for every row in that data set, for every record in your data set, it's going to create another copy of that symbol with a reference to the data for that particular record. So let's come back here and say, okay, well, we know we want to do this for our source data. So this should be giving us 1,000 dots now. Now, you're not going to be able to see that there are 1,000 dots here because all the dots are getting plotted on top of each other. And that's because we haven't really made this part data driven yet, the kind of x and y. So let's do that now. Now that we've kind of joined this data to the symbol, we can actually use data references in here instead of discrete values. So we saw here how we did a discrete value of 100 by using an object with the value property. But if we go back to the documentation and we look at some of the properties, like let's just go straight to the symbol, look at the sort of the x property. This is not where we want to be. This is part of why I want to show the documentation, is that it's not always clear how you define values like these. There's a section of the documentation called types that is pretty helpful for this. It's got the different kind of types you can put in here, and we were just linked directly to the number, but the number just tells us like what a number actually is. But in marks, you can actually provide what are called field values as well. So in a field value, instead of providing kind of the raw value, what you can do is reference a field of data inside of what you're currently kind of looking at. So for example, I believe you change this to field, and we would say make this petal width. And you'll see we're getting a bunch of circles now. You can kind of tell because they're slightly spread out, and the reason they're slightly spread out is because the petal width really only goes from like 0.2 to I forget what the range of it was, right? But it doesn't have a lot of difference in those pixels, right? That's what our mapping was from. But this is how you would do sort of a field value, where we're saying, okay, instead of using just a discrete value here, look at each record for each symbol and then pull out the petal width value. This isn't really enough for us. We need to scale this based on our x scale, right? So the way to do that is you actually just add a scale reference like so. So you can just say scale, and you give it the scale name. And now the dots are spread out across an X scale. So based on that, you can probably guess what we're going to do for the Y value then. We can come here, and instead of doing petal width, we'll do petal length. And instead of X scale, we need to make that Y scale. And now we've got this pretty nice looking scatter plot. And we can make a few other changes to this to make it maybe a little more obvious what's going on. I'll use the enter just to show the difference there. For the enter properties, we'll put a property that's never going to change, so we don't need it in update necessarily. And that's the opacity, and we'll do a value of 0.5. And so now we have these kind of dots that are slightly transparent, so we can see a little more about the overlaps between them and things like that. Okay, so what's pretty cool about this is we built this scatter plot. It's embedded into our web page. We've seen that we can make it somewhat dynamic by changing properties of it, using the runtime. And really, it's not a lot of code to describe this thing. I mean, the spec, it ends on line 58. It started on line 6, so it's about 52 lines, a lot of which is just some simple boilerplate. You put your data in there, define a couple scales, define a couple axes, and define the symbols, and you got your scatter plot. It's pretty cool. So I want to take this one step further and show a little more of like the cool interactive stuff you can do with Vega. And that is, let's actually add in some signals to do some dynamic behavior in our chart. In this case, the dynamic behavior I want to create is that when I hover anywhere in this plot, I want it to sort of draw like a crosshair to the y-axis, showing me what am I looking at on the y-axis, and a crosshair down to the x-axis, showing me what I'm looking at on the x-axis. So to do that, the first thing I need to do is, of course, create a signal that I can then hook into values for. So a signal, just like everything else in Vega, is defined with an object. If we go to the signal def documentation, we will learn a bit more about what can be done with signals and the different properties. So the first one's obvious, is it needs a name and identifier so we can reference it in other places in our spec. So let's call our first, let's call this signal, how about cursor? And what we'll do with this signal is we're going to, there's really multiple ways to define a signal. You can kind of give it an initial kind of hard-coded value that you are going to then update manually from externally with the View API, which allows you to change signals, which is cool because you can use JavaScript in your web app or website to change properties of the visualization. You can use the update property instead, where you provide like a formula where a signal could respond to like other signals. So you can build a whole chain of reactive variables that depend on each other. But you can also link them with events. In our case, events is really what we're going for because we want to get the mouse position inside of this plot. So let's go to the information on event stream handlers and see kind of more. Here's an example of a click in code where it's saying, okay, on events, if you do mouse down, then encode select. If you do mouse up, then make the value release. So in our case, what we're going to do is we want to get the kind of mouse position. Let's see how we do that. Oh, there is a dedicated cursor signal. Maybe we are going to be able to use that. So let me actually show an example. Often when I'm building charts with Vega, what I like to do is just look for similar examples and build off of them. So I'll show you the example that I had in mind that has a similar type of concept is the stock index chart. So stock index chart takes the X value and provides a crosshair while also transforming the data based on that crosshair. So it's doing a lot of interesting things. Really what we're interested in is getting that mouse position and creating a crosshair for our simplified example. So if we look at the symbol, the signal that they use to get that, they call it the index date. They give it sort of an initial value of the beginning of the time period being shown, or maybe it's the middle of the time period, I guess. Yeah, the middle of the chart. And then they provide this kind of on update, which says when the mouse gets moved, invert these values to produce well, we'll walk through what this does. So let's go ahead and copy and paste this, and we'll see what we're going to do to change this a little bit. We're going to break our X and Y kind of crosshairs into two different values. We're going to have the we'll call one our sort of X crosshair, keep this simple, and we're going to initialize it as just a null value, and we're going to say on mouse move we're going to invert our scale. So what's pretty cool here is that we can get the X value of the cursor inside of an expression by calling X like this. And we can take that value and invert it to it with a scale to get what the scalar kind of value would be. But for now, let's just get so we'll call this the X crosshair. We'll get invert. This is going to be X scale. So we're going to take the X scale and take the mouse's X position and reverse that, kind of put it backwards through the linear scale to get back out what the number should be, so we can kind of draw the number. We'll do the same for the Y crosshair. In this case, we're going to invert the Y scale, and we're going to use the Y position to get that. So we have some values for an X crosshair and a Y crosshair. Now what I want to do is I want to draw a line based on that data. I want to draw a line just straight through the page for whatever the X crosshair is, for example. So what I'll do is I'm going to go to my mark section now that I have that X crosshair signal defined. And I'm going to add another object, right? It's another mark. Before we had the symbol. Well, now what I want, if you look at the documentation, is I want what's called a rule symbol. So a rule is basically just like a straight line. So a line with one starting point and one ending point. As opposed to when you think about lines in Vega and other charting libraries that have multiple points, like if you're creating a line chart. So let's create the rule marker, and we're going to need to give it some properties. In this case, we're not doing a data join because we're going to use the signal data that we've captured. And so this is going to need an X property, it's going to need a Y property, and it's going to need X2 and Y2 as well, so we can draw starting and ending points. So we'll do X and X2 and Y2. And so let's just get this working statically first. So let's say if it was at like 100 or something like that, and this was at 100, and let's just draw a line sort of through the middle of the plot. Oh wait, sorry, this should be 0. So there's a line. Now it doesn't go all the way to the bottom of the page yet, and it's not really placed on the X based on our mouse cursor. So far it's not really interactive, but at least we have sort of a line being drawn there. Well, before, today we've kind of looked at these literal values that you can supply, and we've also looked at field references, but you can also use signal references in here. And for example, one of the signals that comes automatically with the Vega spec is the height. So if I change Y2 to be a signal of height, now I have a line that always spans the entire plot. So far so good. So the only thing I really need to change then is the X, which I want to be based on my X crosshair. Or actually, I don't even think I really need that one. I think I can just do something like that. Uh-oh, getting a problem. Right, okay, the X only works inside of mouse events. So what I do want my signal, I want the X crosshair. Now you'll see that it's like only moving, it's not really moving where we want it to, and that's because it's not really like scaled properly, because we ran it backwards through our scale because we're going to use that X crosshair value to show the actual value that's being, in some text later. But what I can do is actually just scale this again. So I can say, okay, we'll apply the X scale to this. And now I've got a nice little crosshair here for my chart. And so now repeating this for the Y is pretty simple. We can just copy and paste this. And we do a rule. We make this the Y crosshair. And this is the Y scale. And these should become Y and Y2. And this should become X and X2. And this should be width instead of height. Right? And now we've got sort of a crosshair pointer on here. Now, the reason that I didn't just like get the X value and store it, but I actually scaled it, is because you may have noticed in NAR, for example, like we actually referenced the selections like across multiple charts. So it could be useful to sort of store the actual value that you're wanting to annotate in case you need to put that value in other places outside of the chart where the kind of hover direction, or sorry, the mouse position may or may not be important. So if you were to build multiple of these where like the cursor was shared across several charts, you could do it this way and pipe those signals out. So we have the value, the X and Y crosshair. We can also put the text in now, so we could create a text mark, for example, which will encode with an update. It's going to be based on a dynamic signal. And the X position of that text is going to be, I guess for the X, we want to put it just like at the bottom, or maybe at the top, maybe at the bottom. How about that? So we'll put it right where the X crosshair should be. And we'll do the Y at the bottom. And we'll make the text equal to the X crosshair value that we have here. So now you can see we have a nice little value popping up down there. Now, of course, you're going to want to add like margins and stuff like this to make it all look nice and clean. And probably like restyle this stuff. Those are all things that are pretty easily determined from the Vega documentation. So I'll leave that for you to figure out. But let's see, maybe just really quickly showing you can actually do offsets here. So I could technically do some offset, like I think 3. I think you can do just direct values. Yep, and then maybe an offset here, -3 or something. Okay, so there's that X value kind of sitting here. I can see where I'm hovering, and then we can repeat this for Y. So we'll call this this one X, this one Y, this the Y crosshair and the Y scale. This should be width, and the text should be the Y crosshair. We don't want it at the width, actually. We want this to be just at the value 0. So we'll just put 3 here. And we actually want this offset. Yeah, the interesting thing about text. Well, we could just bump this up till it kind of sits below the line. But if you work with SVG text before, then or any kind of text on the web, probably you're aware of kind of like the alignment baseline, which is a property we could change. So we could set it to be hanging so that it was hanging from that Y position. But this accomplishes the same kind of thing. So there you go. We've created a scatter plot. That scatter plot is dynamic, both in the way that you sort of can define the dimensions of it, but also you can define dynamic behavior within the scatter plot using signals, so creating sort of reactive variables that can be referenced in other places in the spec, so that now we have this kind of crosshair system in place. There's other tricks you could do to do things like make the lines disappear when we're not mousing over. I'm not going to show that today, but maybe real quick I'll show you how you pass the data in programmatically, because it's not totally obvious. So what I'm going to do is just like create a button in here, and we'll call this button like, get data or something like that, and draw. And the idea here is that instead of just like loading this data set in line, let's create it where you have to get a button that fetches the data. We're not actually going to do a fetch here, but pretends to fetch the data and then adds it into the Vega spec on the fly and then redraws the chart. So what we're going to do first is actually remove the data that we provided. So we're just going to make this an empty array. So the spec, the view by default is not going to get really any data to come with it. So you're going to get this kind of empty looking chart here. So what I want to do next is I want to say when a user clicks the fetch button, we want to, let's go ahead and take this off too. We want to draw this chart. We want to add this data to the chart and then draw it. Well, I'll show you where in the documentation you can find out how to do this. In the API reference under the view, there's a section called data and scales. And if you go down there, you'll see a section about Vega change sets. So being able to call view.change, where you provide the name of a data set that's defined in your spec, and you provide a change set. So what is a change set? A change set is essentially a description of how data should be added and removed from the existing data that the spec has. This is useful if you're doing sort of like incremental updating of a chart, like maybe your chart already has some data in it and you want to insert the rows that are missing, keep the ones that need to stay from the data set, and remove the ones that are no longer part of your data set. You could do that this way. In our case, we're going to do something a little more kind of brute force method, which is that we're going to just drop anything that already exists and then insert new data. This is a common approach if you don't care about what data is coming in and out and you just want to like always show the freshest data. You don't care if it reprocesses that whole thing. That's what I've commonly done with working with data coming from APIs. So let's see how we do this here. The first thing we need to do, of course, is like just hook into our button. So we'll get document.query selector. Let's get element by ID. Let's get our button and add a click event handler. What we're going to do, on click is we're going to pretend like we fetched that data. We already have it, and we just kind of imported it manually here. But we're going to create a new change set for the Vega view. So I'm going to import from Vega the change set module. And I'm going to create a variable called changes, which will be our change set. And to create a change set, you kind of initialize one by calling the change set function. And then from there, you can define insert and removal rules for the data. So the way this works is that for remove, you give it a function that'll be tested against each record of the data, and that function should be a predicate, so it should return true or false. And if it returns true, then it drops the data set and that record of the data, and if it's false, then it keeps the data. So if you want to check if the data already existed, you could create some sort of predicate function here. In our case, we don't care about that, so we're just going to always return false. We're not going to care what this first argument has to tell us. So when you are writing this function, though, the D there, the first argument or parameter, will be the record that it's currently evaluating in your existing data set. And you can figure out if you want to keep that or not. In our case, we want everything to be removed, so we're going to always return true. Everything needs to be removed. And then we'll do our insert, and our insert is simple. We'll just insert the data we have, which is going to be called data set. Okay, so there are our changes. Now that we have this kind of change description, we need to apply it to an actual data set in our view. So what we can do here is we can take the view, and you can call .change on it. So .change, as you can see from the helper text here, takes the name of the data set and then the change set you want to apply. So we want to apply this to our data set called source. These are the changes. When working with the View API, you can do kind of this dot chaining. So I've got the changes that I'm going to apply. I could do my width and height thing like I did last time. But once I'm done sort of describing all the things I want to change in this view, then I can call .run to execute those changes. So there we go. I have this, and now if I want to get this, let's turn hovering. Oh, we do need hovering. If I click Get Data and Draw, you'll see that it draws the chart there. So again, let me just save this and refresh so we can start from scratch. It already did refresh it. Cool. So there it is. There's no chart. I say Get Data and Draw. It programmatically is going to insert the data and then change the width and height and then re-render the entire view. So I'm going to click the button, and there it goes. So if you wanted to, fetch different data sets that were going into this, this is how you would do it. Every time you want to add new data in, you would just create a new change set, create some rules about what to do with the existing data, and then what to add as the new data, and then add that change to the view and re-execute the view. So I hope this video helps you. It went pretty fast, but hopefully you can pause and learn more about using Vega and how to use it on the web with kind of dynamic data and dynamic interactions. I will put a link to this code in the comments below.